Hello, I'm Mr. Rhodes and I'm one of our physics teachers for AS and A2 physics. This is an A-level of physics that is taught by both myself and by Mr. Watson. So key headline things about the course and how it will be examined. For AS in physics, there are two external exams that usually take place in May. They're called breadth and depth, as the name suggests. One assesses how wide-ranging your knowledge is, and the other drills down into the detail of your understanding of physics and looks at your problem-solving skills. For A2, there are 3 papers that are sat externally in the May examination season of the second year, so in year 13. These are called Modelling Physics, Exploring Physics, and Unified Physics. Modelling Physics assesses content from the modules 1, 2, 3, and 5, which there's going to be an overview in a moment on the next slide. Exploring Physics assesses content from modules 1, 2, 3, and 6. And Unified Physics looks at your understanding of ideas and principles that are linked throughout the entire course of study. So that is more synoptic in its overview. In terms of how the course is delivered, for AS, it's approximately 185 hours worth of 5 hours of directed study. And for A2, that's approximately 350 hours of directed study split across 2 years. For UCAS, AS levels are worth up to 20 points and A2 levels are worth up to 56 points. Okay, how it's delivered at the UTC is usually it is taught in 5 lessons split across 2 teachers. And in terms of the examinations at the end of the course, so in the May examination season for both AS and A2 physics, it is 100% assessed. There is no coursework for this study. However, there is a required practical element that gives students the opportunity to build up competence in key experimental skills. And that's makes part of the practical endorsement, which is part of the course. And students will either get a pass or a fail on that, but it doesn't affect the overall whether the students have passed or failed the A level. Looking at the course in terms of breakdown, there are 6 modules of study split across AS and A2. In year 12, so AS physics, you build on a lot of the foundations that you studied at GCSE, the concepts of energy, mass, wave motion, and charge. And what it does is it builds these beyond, extending to look at developing detailed descriptions of moving systems, models we can use for explaining electrical properties, and introduce some new phenomena that you won't have seen before in the form of quantized behavior. In year 13, it takes the concepts that will have been built on in year 12 and built on them further. Year 13 does include some more challenging content, which is really interesting. So majority of year 13 is spent looking at the ideas and developing our understanding of fields such as gravitational, electric, and magnetic fields, and the phenomena associated with the interactions of fields. So electromagnetic induction, which is a big staple of how pretty much any electrical device is powered or works in the UK. It also extends into particle physics, which is a good foundation for students wanting to look at a career in the cutting edge part of physics. One of the nice things about the course we teach at the UTC is it is quite heavily linked to application. So, for example, particles and medical physics is studied in a sense of how we can apply the knowledge of what learning in particle physics and look at its real-world applications and the engineering challenges that are involved there from a theoretical standpoint. Who is this course suitable for? So A-level physics, an A-level in physics is one of the most universally accepted qualifications for progression to university. The course content covers the basis of how things work, from constituent parts of atoms to the extent of our universe. You'll integrate the concept studied with a range of practical experiments throughout each topic, giving the course both an academic and practical focus. And you learn to apply your knowledge of the key concepts to solve problems in a range of different contexts and applications. It's ideal for students who are interested in science, technology, engineering, or maths careers. Of course, people who are curious about how things work, how the universe works, interested in finding out how new particles are discovered, and the students who find it rewarding to solve problems. Where can a physics A-level take you? Can take you pretty much, as quite predictably, along pretty much any STEM degree, so science, engineering, and maths. Particularly is required for physics, is strongly recommended for maths, and is often required for engineering. Advanced apprenticeships industry, including aerospace, nuclear power, and electrical power distribution and generation. They are also interested in applicants with a physics A-level. In terms of resources that you will need, a lot of it is actually to do with your confidence and your background knowledge. So you need to be confident that your knowledge of the fundamentals of higher tier GCSE physics and higher tier GCSE maths. For example, can you rearrange equations? Can you solve? Can you mathematically formulate expressions that could help you to solve problems? Can you explain why a particular phenomenon occurs, looking at the ideas that are linked with that phenomena? And more importantly, in the context of AS physics, can you apply and use your understanding of ideas of physics in unfamiliar situations? One thing you probably do need to go out and buy, though, is a good scientific calculator if you are coming to study physics. Okay, in terms of where you can find out further information, you can either contact either myself, Mr. Watson, or Mr. Rhodes at the UTC. I've put Mr. Watson's email address on the slide there. And that's about it. We look forward to seeing you studying AS or A2 physics next year.